Morning, everyone. Okay, I think we'll begin the session. Again, welcome everybody. We appreciate your time. I hope you found this session useful. So it's basically we wanted to introduce you to the a new solution from our partners Altair. Well, it's an old solution, but it's new for us, and it's called S-Concrete. And basically, just want to quickly go through the agenda, and then we can introduce ourselves. So just want to introduce ourselves. There's three of us presenting this webinar while I'm actually hosting. And then my colleague Tyan here will go through S-Concrete and S-Line overview. And then another colleague of ours far away from here will actually has pre-recorded a session. It's on S-Concrete product overview. So we'll go through the live clicks to give you appreciation of what the S-Concrete software looks like. And once that presentation has finished, then we'll have an opportunity to go through some Q&A. So while you are going to this session, I would really sort of suggest, and if you have any questions, just put them in the chat. And then when we go towards the end of the sessions, we can go to the Q&A. Now, just a little bit of formal introductions. So we have myself introducing the session. So I'm Wasim. I'm the simulation manager for Symmetry Europe. I'm based in, I call it Middle England, in Burnley in the United Kingdom. I've been with Symmetry now over 15 years. And my background mainly is I'm a mechanical engineer, not a structural engineer. And this is obviously this is where Tyan comes into. So Tyan, do you want to say a couple of words about yourself?
Yes, thank you, Wasim. So, my name is Tyan Aguilar. I am a solutions engineer at Altair. I have been with Altair for over 2 years now. I have a background in civil engineering. I'm a structural focused. I am originally from Mexico, but I am based in Madrid, in Spain. And my focus is on the AEC sector of Altair's solutions.
Thank you, Tyan, for that. And then we have a third colleague. Obviously, you can see by the slide, he's based in Vancouver in Canada. So I think he's probably still sleeping. And he's the global technical team manager and the expert on S-Concrete and S-Line. So hopefully we just managed to get him to record the session. And then you get an idea what the software is about. But before we go through the live presentations, I just wanted to get an idea. So before we go into Tyan's overview, we want to get some sort of an idea what you guys are currently using. So Justina, can you put the first poll on? I just want to get an idea what you're currently using. So I would appreciate if you could actually give us an indication what you're currently using when the poll goes live. So the button in the polls. So if you just simply tell us what you're currently using, the poll button will be in the bottom right-hand corner next to the questions. I can give you a couple of seconds for everybody else to click on the poll. Okay. Well, thank you very much for that. So we get an idea that most of us here are using Revit. Some people are using Tekla. And obviously we can't share it. It's just we have a new platform. So thank you very much for that, Justina. If you want to then start the other poll. And the other poll basically is about any analysis software you are currently using. Okay, now this one's interesting. So just to give you an idea, so we got Robot, the prime used software, then we got Start Pro and Tekla as the second most popular. And thank you very much again, Justina, for that. So now, Tyan, if you want to give us a quick overview of what the S-Concrete and S-Line software is about.
Of course. Thank you very much, Wasim. Let me just share my screen. Okay, so you should see it now. At Altair, we have a different set. Sorry, we have different sets of solutions for the AEC, and we like to divide it in two major play fields. One is the code-based analysis, and the second one is the FEA analysis. Today, we're going to focus in the code-based analysis, but here you can see a diagram of how our solutions integrate and how they interact between each other. At the heart of our offer is our FEA software for structural analysis, SFrame. And from there, we have the different materials and different solutions, such as timber design, concrete design, which is today's presentations focused. We have a section calculator. We have a steel design modules, foundations models as well. And all of our tools have different interoperability with third-party softwares, such as Autodesk solutions, Revit, which is something that is very commonly used in the industry. You can bring your models from Revit, and you can also take them back into Revit, as well as with Tekla. If you have something built and analyzed in Tekla, you can bring those models and those calculations, those analysis into our concrete design solutions. Also with the Microsoft Office, different platforms such as Excel and Access, we have a lot of interoperability. Those databases, those spreadsheets where you have all the information, it's very easy to either copy and paste it into our solutions, which are spreadsheet based in many cases. So it's really easy to just share the information both ways. Similar things happen with Access. Many of our tools have the ability to read those Access databases. And we can also export these reports. Everything that our solutions produce can be easily exported into a Word document, so you can share it with your peers, with your different colleagues, etc. And you can also bring results from third-party FEA softwares like ETABS and StatPro. So you can execute your analysis in your preferred FEA solution, and then bring those results into our concrete design solutions, which is, like I mentioned, the focus of today's presentation. When it comes to concrete design, S-Concrete allows you to code check and design concrete sections, and S-Line allows you to design continuous beams of concrete. We have code checking capabilities for different building codes, such as the Eurocode 2, the UK annex. We have American codes like the ACI and CSI. So depending on where your project is based, we have different building codes available to you. We are continuously adding more codes. Now, when it comes to continuous beams, we have GFRP design, which is for reinforced with fiber, with the specific code of the ACI 440. Along with this, we have a very powerful multi-story designer, which allows you to bring all of your model information from ETABS and batch design all of your elements, such as columns and piers, the beams, code check them, and export them very easily. And within this batch processing, all of those elements that are processed and code checks can be easily reported. So you have like a summary of all of each one of the elements, which you can later check individually. So this really accelerates the process of designing concrete elements while maintaining a very high level of accuracy, precision, and of course, customability. Now, when it comes to the reinforced concrete beam design, we have different section types that are available on S-Concrete. We have rectangular, T, and L type beams. You can edit the river with just the click of a mouse. You can also have custom bar sizes. All of the code checks are instantaneous. So everything that you do while editing the geometry and the disposition of the rebar, the size, is going to instantaneously tell you if the code check is passing. For this type of beams, we also have torsional checks. When it comes to the columns, we have rectangular and circular sections with different rebar layouts. You can go with rectangular, circular, or spiral rebar. The moment magnification in columns can be applied due to slenderness. And when it comes to walls, which is the third type of section that S-Concrete supports, we have rectangular, I, C, T, and L walls. When it comes to the walls, it is divided by different panels and zones, so you can completely customize the type of wall that you have with different panels, with different sizes. They can be symmetric, they can be isometric, and you can specify the rebar in each one of these zones. So it's completely customizable. And when it comes to the loading, you can also divide it within the sections and the panels. So it's very easy to represent in a great way this type of sections. So yeah, I think that's for the overview in general. We could jump now to the next part.
Thank you, Tijn, for that. So let me just. I'm just going to share next part. So the next part is going to be a demonstration on the S-Concrete. Now, as I mentioned before, Matthew is obviously far away, so this session is going to be pre-recorded, and hopefully it will give you an appreciation of the software. So Justina, do you want to play the video?
Hello, everyone. My name is Matthew. I'm the Global Technical Team Manager for the AEC Group with Altair. I'm based in Vancouver, Canada. I'm apologizing in advance for not being able to join you today. The time zone didn't unfortunately work out that well for me. But I do want to introduce you to the S-Concrete ecosystem. So here we have an example of the S-Concrete interface that I'm showing. And in this situation, I'm showing a rectangular reinforced concrete beam. But as you can see, we support a variety of what I will consider your standard reinforced concrete shapes. And S-Concrete is a really powerful tool to code check, design, and detail these reinforced concrete sections for you. So you can see you have columns, beams, as well as walls. And we can perform design checks, produce the engineering design reports that are required to pass along to whoever needs to consume them next in your design workflow. I'm going to start with a beam design. And as you can see here, I've got a 600 by 500 millimeter beam. And I have a variety of reinforcing bars around the outside, as well as some face steel in between the top and bottom layers. And you'll notice at the top of the screen we have this status report for our section. And it's showing me an overall status of unacceptable. Then I have two other types of statuses. I have a V&T, shear and torsion utilization, and an N versus M, an axial load versus moment utilization. And you notice here the numbers associated with each. So I have about 76% of my shear and torsion capacity being utilized based off the demands I've imported. And for my axial load versus moment, I have about 130%. So clearly what this is telling me is based on the applied loads that I have a problem with my moment capacity that is exceeding my demands are exceeding my moment capacity by about 30%. Now to explore this a little bit more, I can go to the edit menu and go to loads. And we can see here that we have this spreadsheet that contains a variety of different factored load cases or combinations that we can then use to formulate our demands. Now, these can come from any analysis software, as Concrete doesn't need to work with any particular analysis software. And obviously, you can easily copy and paste this data in from Excel, or Access, or whatever program that you prefer. Now, what's happening behind the scenes here is that S-Concrete is performing design checks on these sections. And if I go to the results report, I can click on results report, and I get a nice documented engineering design report that's showing me the details behind what this calculation has done. So here I can see the overall status and the utilization ratios again. As I scroll through this list here, I can see my input loads. And then further down the list, I can see my axial load versus moment utilization results. So this is showing me my governing load combination is number 3. This is where we can see load case or combination number 3. And it's showing me in this situation here that my applied moment is 512 kilonewton meters. And my moment capacity is just under 400 kilonewton meters. So naturally I have a failing utilization. I get the same sort of report for my shear and torsion utilization. This time I'm not failing, I'm getting a utilization around 0.762, so 76%. And I can see the values that are being used for each one of these calculations as well. So we're not trying to hide that information. We're trying to present you with all the information you need to understand the design checks that are performed. And it's not just strength checks as well. We are also doing detailing checks. So if we're looking here at the requirements for links, we can see here the spacing of our links and whether or not the spacing is being satisfied, as well as the requirement for our longitudinal steel requirements, crack width, and more. So if I scroll down to the bottom of this report, I can actually get a list of messages. And what's nice about this is that it's showing me clause references for each violation of the code that I have, and it will point me to the direction that I can then find in the code book where that violation is and whether or not I agree with the assessment that S-Concrete has performed. Now in the case that I'm in, we can see again, and reminding ourselves that we have a failing N versus M utilization. I can also see that in the interaction diagrams that are produced under N versus M. And I can see where my particular load combination that's failing lines up on this interaction curve for different theta angles as well. Knowing this, I need to understand how I can reinforce my concrete section differently, and we can take advantage of the edit reinforcing dialog to go in through different forms to change our reinforcement, but there's actually a better use of this interface that uses the interactive hotkeys. So we can see here the number of bottom bars, for example. We have 2 H25s plus 2 H25s, so it's the same thing as 4 H25s, but we're separating them because we can have different bar sizes in different layers, or in the same layer rather. So if I wanted to increase the number of bars, I can left click on this number 2, and it's going to increase the number of bars, and we can see that utilization ratio has dropped slightly. Now we have 5 bars along the bottom. And I can do the same thing on the top by just left clicking on H25, and you can see that utilization ratio continues to drop. I could also left click on the H25, and this will jump up to an H32. And now we can see that we're getting into the realm where we have a passing code check. We still have, despite the fact that our strength checks are passing, we still have this overall status of warning, and we can go into the results report. And we can see exactly why that might be. I'm just going to jump right to the list of messages, and we can see that we still have some detailing issues. We have some crack widths around the top bars exceeding the limit, and the bottom bars, and then our issues with leg spacing as well. For the sake of this demo, I'm not going to go into too much detail on how we can remove all of those, but as you can see, it's a very easy to manipulate interface that we can work with. However, I'm now going to jump into column design. And you can see here with the rectangular column that I have currently selected, I'm using the same loads that I had on the previous section. But what we're going to do is we're going to look at some different ways that this can be designed. So in this particular scenario, we can see that we have our utilization ratio just under 1, which is great, for both shear and torsion. But let's just imagine that the architect has told us that you can't go greater than a depth of 550 millimeters. In fact, we want this to be a square column, 450 millimeters square. So I'm going to actually left click and drag this until I find the 450 millimeter section size. There's also a way to enter this in the edit section dialog, so I don't have to left click and drag. But what I can see here is that when I reduce the section size, we're now getting a failing utilization. Now I could go through the same exercise of going with the increasing number of bars. So maybe I want to go from 16 to 20, for example. or go up a bar size. And as we do that, we are getting closer to a solution. However, as you can see, with this many bars and this type of layout, it may not necessarily be a practical design, and that might be why we're failing some of these detailing checks and have this warning status. So if I just back off here and I go with the original setup, another option that we can do is we can set up our own design constraints, and we can have sConcrete validate or iterate on the design and come up with an approximate solution for us. So in this scenario, I'm going to say, let's just freeze the dimensions of this section. However, I'm going to allow it to adjust the other parameters and see if it can come up with a design that works for us. So once I've set that design constraint up, I can go ahead and run an automated design. And I'm going to go with the auto option, where it's just going to basically iterate on different design settings until it comes up with a solution that works for me. And in this particular scenario, we can actually see that it came up with a passable solution where it gets a utilization of 0.974 for axle load versus moment, and shear and torsion is 0.881. And we can see here very clearly what has changed throughout this design process, what parameters were frozen, and what's been left unchanged. So it's very easy for us to understand what has gone through. And of course, we're still able to produce those engineering design reports that we had. Now with columns, we add a few extra details that are existing in both columns and walls. For example, if I go to the Edit Section dialog, we have the ability to consider slenderness effects if we want to evaluate minimum moment requirements and so on. We can consider that within this dialog here. I'm now going to jump into walls, and I'm going to go with the C-shaped wall as my example. As you can see here, we have naturally, with the same loads, different utilization ratios since this is a larger wall. If I go to the Edit Reinforcing dialog, we also have additional parameters that can be adjusted for our reinforcement. So we have two different categories of reinforcement. We have zone reinforcement and panel reinforcement. And you can see that we can adjust each one of them individually. So if we want to work on our concentrated reinforcement, we can make that more precise than rather just having the entire wall designed as one single group. The same goes for our section loads and our panel loads. So if I go to the Edit menu, under Loads, here we can see that we have two tabs. We have a sectional loads table, which contains the loads applied to the entire cross-section, this pier of our wall here. And we also have panel loads, which might be handy if we want to induce certain shear forces, for example, in one of our wall panels. We can design particularly for that one load in that one panel. And just like with columns and beams, we get all the same information. Our design reports will include, we get the N versus M diagrams. So here we can see where our section is going to be aligned on this N versus M diagram and where those factored loads are going to fall on this particular plot. Now it's worth noting that we do have ways of actually bringing in data from structural engineering programs, structural analysis programs rather. For example, the location of our sections, the size of the sections, the demands in those sections, and more through what we call the multi-story designer. And if you'd like more information on that, you can find more details on the Altair How To YouTube channel. Now, one other aspect I do want to bring up is the S-line, which is available in sConcrete. And basically, this is taking what sConcrete does for section design, but applying it to an elevation design instead for beams. So you can see here it has information related to stirrup spacing, bar cutoffs, and so on. And we're looking at, in this case here, continuous multi-span beams. So I can set up my reinforcement, I can adjust my reinforcement, and go ahead and run an analysis in CodeCheck. And we get our code performance metrics, so we get our utilization ratios for the strength checks, as well as the overall status warnings. I can go into the results report, and I can see here a very similar looking detailed report for each bay in my model. And I can scroll through and see information related to items that wouldn't necessarily be captured in a concrete section design tool. Things like stirrup spacing, for example, where we have different segments of our beam that might have different stirrup spacing. We also have crack control checks in this scenario, and I'm actually using a glass fiber reinforced polymer rebar for this particular concrete, so I'm using a different code for this aspect. But we still get all the same information for result reports. So we can actually look a little deeper because we have run an analysis. So I can look at deflection diagrams, look at all the different load combination results in this particular diagram, scroll across this and see what the demands on this particular section are at different locations. I can see my moment, capacity envelopes and the demands there as well. And the same thing goes for shear and for torsion. I can see this on any of the load cases or any of my beam spans as well. So if you would like more information on S-Concrete, we do have dedicated training, but feel free to reach out, or if you have any questions, we'd love to hear from you then.
Okay, so I think time for some questions. So just let me share my screen. So if you've got any questions, by all means, put in the chat or the questions panel. But one of the questions which has come up is basically asking whether the license is a network or a standalone. It's available as both, but it can be available as a network license, so anybody can use it at one time. And
Yep.
Is that right?
Yeah, that's correct. And we actually have another question regarding how to find more information about the multi-story designer. I am going to paste here in the links the link for our YouTube Altair How To channel, so you can visit our YouTube channel and just look at all of the videos that we have on concrete design for walls, shear walls, etc. So you can put it here.
You're putting in the link section or in the chat link?
I'm going to paste it on the chat now. Just yeah.
In addition to that one, just for your information, in the apps section, I have also put in a link to the S-Concrete page on the Altair, so you can have more information on what the S-Concrete and S-Line is all about. And just one more question, Tyne. What's the most common question or popular question people ask around S-Concrete or S-Line? I mean, what is the most common question people ask?
If you can code check instantaneously and what is the software doing, you can always check what the software is doing. It will tell you the class that it is comparing it to, so you can have your manual on one hand and S-Concrete calcs on the other, and you can compare one-to-one what is going on in the background, and you can check all of the hand calculations so you can rectify everything that is happening.
Okay, thank you for that, Tyne.
Yes.
Okay. Well, I would like to thank Tyne. Obviously, Matthew was not here, and I would like to thank everybody who sort of took their time out of their busy schedules to have a look at S-Concrete. We will be sending out a recording. If you have any questions, do please get in touch. And again, thank you very much for joining us.
Thanks to you, Wasim.
Thank you. Bye now. Bye-bye.